You ever look at a problem and just think, there's no way, it's completely impossible? Well, now imagine that same problem had stumped the smartest people around for, 100 years. That's the story we're getting into today, all about one guy, Filippo Brunelleschi. His genius didn't just fix an engineering nightmare, it totally changed how we see the world itself. So, that's the big question, isn't it? How do you solve something that's beaten everybody else for a century? I mean, it's the kind of problem where you just have to toss the old rulebook out the window. And for Brunelleschi, this wasn't some thought experiment. Nope, it was a very real, very huge challenge, literally staring down at the entire city of Florence.
And when I say a giant hole, I am not kidding. We're talking about the magnificent Florence Cathedral, Santa Maria del Fiore. They'd been building this thing for generations, but nobody, and I mean nobody, could figure out how to put a roof on it. This opening was almost 150 feet wide, and it started 180 feet up in the air. It was more than an architectural problem. It was a huge, gaping symbol of the city's biggest failure.
Okay, so before we even get to how he solved that massive engineering puzzle, we've got to back up a little. We have to look at how Brunelleschi first changed the world. See, to build something totally new, he first had to see the world in a totally new way. And this is where it all started, not with bricks and mortar, but with art. You know how for centuries paintings just looked kind of flat? The proportions were weird. There wasn't a real sense of depth. Well, artists were really struggling with that. But Brunelleschi, who was an absolute whiz with geometry, became obsessed with cracking that code. He figured if he could just map out the world using math, he could create a perfect illusion of reality on a flat surface. So how did he prove his crazy idea? With this incredibly clever little gadget, basically a peep show. He took a small panel and painted the Florence Baptistery, the building right across the square, onto it with insane mathematical precision. Then he drilled a tiny peephole right through the panel. Here's the cool part. You'd look through the hole from the back of the painting into a mirror that would then reflect the painting back at you.
And the effect? It was absolutely mind-blowing. Because he controlled exactly where you stood and what you saw, the painted reflection in the mirror lined up perfectly with the actual building. It was seamless. His biographer, a guy named Minetti, actually tried it himself, and he wrote that it was like you were seeing the real thing. It was this incredible, almost magical demonstration that, yeah, his system worked.
And that system? That's what we now call linear perspective. It was this revolutionary idea that married art and math. For the very first time, artists had a foolproof, geometric way to create believable 3D space. I mean, think about that. Brunelleschi literally gave the world a brand new way of seeing.
All right, so that breakthrough in seeing things differently was absolutely crucial, because that exact same mathematical brain, that same geometric genius, is precisely what he was about to apply to Florence's biggest problem, that so-called unbuildable dome.
So, here was the deal. The dome was just too big and too high for the normal way of doing things. Usually, you'd build this huge wooden skeleton inside, called centering, to hold everything up. But for this dome, you would have needed a whole forest, and it still would have been super unstable. Plus, just the crushing weight of a solid dome would push the walls outwards, and the whole thing would just collapse. So what's really key to understand here is that Brunelleschi didn't have just one magic trick up his sleeve. Nope, he had a whole collection of them. What he proposed was a totally radical system of interconnected ideas where each one supported the next, creating something that was stronger, lighter, and could pretty much build itself.
Okay, first brilliant idea. He proposed not one dome, but two. An inner one nestled inside a totally separate outer one. This, right here, was a complete game changer.
Think about it. This design solved a bunch of problems all at once. First, two thinner shells are way, way lighter than one giant solid one. That immediately reduces all that outward push on the cathedral's walls. Second, the gap between them was perfect for putting in stairways so workers could get up and down. And finally, that big outer shell acts like a raincoat, protecting the important inner structural shell from the elements. Brilliant.
And you can see it so clearly right here. That inner shell is the real workhorse, providing the structure. Meanwhile, the taller, wider outer shell is what gives the dome that iconic shape we see against the Florence skyline. It's both beautiful and unbelievably efficient engineering.
But even with the lighter double-shell design, you still have this problem called hoop stress. It's just physics. A dome wants to spread out at the bottom. So Brunelleschi needed something to hold it all together, to squeeze it tight. And his solution was basically to treat it like a giant barrel, wrapping it with huge hoops or chains inside the walls.
These weren't just simple iron chains either. We're talking massive rings made of sandstone blocks, chained together with iron, and even a huge one made of wood timbers. And they were built right into the masonry, so you can't even see them from the outside. This clever trick meant the dome didn't need any of those clunky flying buttresses you see on other cathedrals. And as a bonus, it gave the whole structure a bit of flex, which has actually helped it survive earthquakes for centuries.
All right, so the dome is light, it's wrapped in chains to keep it from bursting, but the biggest question of all is still hanging in the air. How in the world do you actually build it? As you go up, the walls get steeper and steeper. How do you lay bricks without them just sliding right off? This, my friends, was Brunelleschi's best-kept secret.
Yeah, this is the part that had all his rivals scratching their heads. As that dome curves inward, gravity is actively working against you. Without that giant wooden framework underneath to hold up every new row of bricks while the mortar dries, the whole thing should have just peeled open and crashed to the ground.
The answer was in the bricks themselves. Brunelleschi took an ancient technique and perfected it. It's called Spina di pesce, which means fishbone. You probably know it as the herringbone pattern.
This was the absolute key. By sticking vertical bricks in every so often among the normal horizontal ones, he created this interlocking zigzag pattern that spiraled all the way up. It was like a zipper. Each new layer of bricks was physically gripped by the one below it, holding it steady even before the mortar was dry. It was genius. The dome was literally building itself, layer by layer, with nothing holding it up from below. And just try to wrap your head around the scale here. We're talking about more than 4 million bricks. Each one had to be hauled up into the sky, laid by hand, and fit perfectly into this incredibly complex, self-supporting puzzle. It's just a mind-boggling achievement of engineering and pure logistics. So when you step back and look at all these incredible innovations, you start to see what really drove Brunelleschi. It all came down to a core belief in logic, in harmony, and in the pure power of geometry.
You can see that logic right here in his floor plans. I mean, they might look complicated at first glance, but they're really just built from simple shapes, squares and circles that are repeated and divided up. It creates buildings that feel mathematically perfect and just beautiful and balanced. Everything has a reason. Everything is in proportion.
And that, really, is his legacy, isn't it? He cracked the code of perspective, giving artists a tool they'd use for the next 500 years. And he built the impossible dome, an engineering masterpiece that still defines the skyline of Florence and just makes your jaw drop. He taught us how to see the world differently, and then he taught us how to build in it differently.
It really makes you wonder, right? When we look at our own impossible problems today, things like climate change or exploring deep space, what massive challenges are out there just waiting for someone to throw out the rulebook? What giant unsolvable puzzle is just waiting for the Brunelleschi of our time to come along?